Before talking about quadric surfaces in the space, let us talk about the definition of trace. A trace of a surface is a set of points at which the surface intersects a plane that is parallel to one of the coordinate planes. A quadric surface has general form as a combination of x squared plus y squared plus z squared and the linear combination of those variables. A quadric surface has general form as a x squared plus b y squared plus c z squared plus dxy plus exz plus fyz plus gx plus hy plus iz plus j equal to 0. As a mathematician, our job is to organize the equation and identify the type of surface that we're dealing with. The equation of ellipsoid is defined as follows. You have x squared divided by a squared plus y squared over b squared plus z squared over c squared equals to 1. If you find traces, the set of points at which the surface intersects a plane that is parallel to one of the coordinate planes, then you're going to see you have ellipses in those planes. One example of an ellipsoid is given to us as 36 x squared plus 4y squared plus 9z squared equals to 36. Well, you might say, hey, what does this equation have to do with this standard equation? Let us take a look at the following. If we divide all sides by 36, we can simplify this and get to the equation similar to the equation of an ellipsoid. So divide by 36. You get x squared plus y squared over 9 plus z squared over 4 equals to 1. As you can see, you have x squared over 1 squared plus y squared over 3 squared plus z squared over 2 squared equals to 1. A is 1, B is 3, and C is equal to 2. equation of an ellipsoid and equation of an ellipsoid as an example here for you. The next one is called elliptic paraboloid. So let us write down the next example for you. Elliptic paraboloid, which has general equation as z over c equals to, we get x squared over a squared plus y squared over b squared. Take a look at the following example. In this example, we have 4x squared plus y squared minus z equal to 0. Our job is to identify this surface. Let us bring z to the other side. We get 4x squared plus y squared equals to z. We need to have the constant on the denominator. So let us divide everything by 4. So we have z divided by 4 equals to x squared plus y squared over 4. Comparing these two equations, as you can see, a is equal to 1, b is equal to 2, and c is equal to 4. So what do we have? We have an elliptic paraboloid. You can use any graphing device to graph this surface, or you can use the traces to analyze the behavior of this surface. The next surface is called hyperbolic paraboloid. So let's take a look at the following. Hyperbolic paraboloid. Well, you're going to have a subtraction between x squared and y squared. So if I change this equation into 4x squared minus y squared minus z equal to 0, I convert that into a hyperbolic paraboloid. You have z over c, which is in this case 4, equals to x squared divided by 1 squared minus y squared over 4. A is 1, b is 2, and c is 4. And here you have the equation of a hyperbolic paraboloid. Next one is a cone. The equation of a cone is written as z squared over c squared equals to x squared over a squared plus y squared over b squared. For example, you might have an equation given to you as 4z squared equals to x squared plus y squared. In that case, if you divide by 4, you get z squared equals to x squared over 4 plus y squared over 4. A is equal to 2, B is equal to 2, and C is 1. This equation represents a cone. Two more popular surfaces are hyperboloid of one sheet and hyperboloid of two sheets. Let's write the equations down here and then go over a couple of examples. The very first equation is x squared over a squared plus y squared over b squared minus z squared over c squared equals to 1. And the equation of hyperboloid of two sheets in standard form is written as negative x squared over a squared minus y squared over b squared plus z squared over c squared equals to 1. One of them has graph as follow of one sheet, and two sheets as two separate surfaces of the following form. For example, suppose an equation is given to you as x squared plus 4y squared minus z squared equals to 4, and they ask to identify this surface. So let us get rid of the coefficient here and the constant here by dividing by 4. You get x squared over 4 plus y squared minus z squared over 4 equals to 1. Now compare your equation with the hyperboloid of one sheet and two sheets. As you can see, here you have equation of hyperboloid of one sheet. A is 2, B is 1, and C is 2. So what we have? We have a hyperboloid of one sheet.